I wanted to have a little bit more fun with Tkinter and graphics and animation, and so I actually tried to do this problem in my class this morning, and I messed it up, but I've had more time to reflect on it, so I thought it'd still be fun, something fun to do. So what we want to do is we want to draw a line and have a wheel roll along that line, okay? So this is just clipped from the assignment from week 4. The only difference is I've made root and canvas global variables. Now, several of you have talked about globals, and I've said global variables are a bad idea. Well, in this case, there's only going to be one root. There's only going to be one canvas. I'm not going to change them anywhere, and so instead of having to pass them throughout my different routines, I'm just going to make them global so they're easy to access. Not generally a great idea, but in this case, acceptable, I think. So first off, we're just going to create a line, and it's going to go from 0, 300 to 800, 300. So it's just a straight line. And I want to create a wheel, and there's something called object-oriented programming, which I would imagine most of you have heard of and maybe you've even dabbled with, and it makes something like a wheel a lot easier to deal with. And so at the risk of introducing a new idea here, I'm going to create a class called wheel, and a class takes a magic function called init, and it takes a parameter self, which is the object that's going to be initialized, and I want it to have an x0 and a y0 and a radius for my wheel. And so we say self.x0. So this creates a variable x0 that's a member of the class object. Okay, so it's different from the x0 in the parameter list. Self.y0 equals y0. Self.radius equals radius. And let's see, self.angle equals 0. Self.spokes equals the empty list. And that's the other thing that I was going to have here in spokes equals 4. So we're going to put a default value for spokes. And so for index in range in spokes, self.spokes dot append, and we're just going to make a spoke be let's see. So a spoke's going to be 2 elements equals index times 360 divided by n spokes. So that gives me an angle proportional to the number of spokes. So it's going to be and I'm already getting in trouble here. Alright. Angles in Tkinter are done in degrees. In math, angles are generally done in radians. So I'm going to have a degrees to radians did that go clear over to there? Oh, because of the other mesh stuff I'm doing up above. Let's just close this off for a moment. Okay. So return, so degrees to radians is degrees times math.pi divided by 180. And then I'm going to have a radians to degrees, and that is radians times 180 divided by math.pi. And if you haven't used radians, don't worry about it. Just they're another angular measure, and this happens to be how you convert back and forth between them. And I'm getting red squigglies because I have not imported math, so we better import math. There we go. No more red squigglies. Okay. X naught equals radius times math dot cosine angle plus x naught. Let's call this spoke x. And spoke y is going to be radius times math dot sine angle plus y naught. And so we're going to append, so the spoke is going to be a list of angle, sx and sy. By keeping track of the angle, that means I don't have to recalculate the angle each time. Is that all right? Yeah, I think so. And then we're going to say self.oval equals canvas.createOval, and it's got to be x naught minus radius, because you draw an oval by giving the corners of a rectangle that contains it. And I want to think of my wheel as centered on a point with a radius. And so this allows me to, this translates back into the terms of the window system. So, of Tkinter, xo minus radius, yo minus radius, xo plus radius, yo plus radius, and then for angle, actually I don't care about the angle here, so I'm going to put an underscore there to say I don't care about that variable, sx, sy in self.spokes okay, so I really need to draw here because I need the object. So ray equals canvas dot create line. So I want to keep track of the lines that are associated with the spokes. X naught, y naught, sx, sy. Okay. And so the ray has to go into that list. Alright. So self.oval has the circle for the wheel, and the spokes are created here, and so this has the information about the ray, and it has the ray itself, which is just a line. Self.spokes.append. Yeah. So ray is canvas.createLine. So if we go to draw scene now, I don't have draw. Oh, here's draw scene. So I'm going to say wheel 0 equals wheel, and this creates an object of type wheel. So it looks like a function call, and it kind of is a call to a knit, but I don't specify self. I just say so it's going to be 50, 250. So that's the x and y of the center of the wheel, and its radius is going to be 50, and we'll give it 5 spokes just to be different. So if we do that, we should see the wheel appear now. Well, that's certainly a wheel with 5 spokes, but they're not evenly distributed around it the way I said they should be. What did I do wrong here? Angle equals index times 360 over n spokes. Sx equals radius math.cosine angle. And we're going to have to go into the debugger because I'm not seeing it right off the bat here. So, and I admit that my debugger looks different from yours, and it would be more friendly for you if I used VS Code, but then I'd make a lot more typing errors, and so I'm making it easier for me instead of for you. I apologize for that. And we want to break in line 39 so that I can see what happens as I go through this loop. So we type continue. Oh, that's right, I can get rid of this one. I don't care about that. Oh, don't do that. So index is 0. N spokes is 5. 360 divided by n spokes is 72. Good. So I want my spokes to be distributed every 72 degrees. And so an angle is 0. Okay. Oh. See, I forgot to convert angle to radians. Degrees to radians of angle. And I didn't actually see the bad calculation, but as I looked at what I was going to do next, I recognized what was going to be wrong. So stepping through it in the debugger helped me, even though I never actually saw the results of that calculation. Okay? So we'll leave the debugger for a moment. Okay, there we go. Wheel with 5 spokes. Now, something I would like my wheel to do is I would like it to move. And again, this is a method of the class, so it has this magic variable self. Self is not a reserved word. It's just customary to use the variable self to represent the object. And we're going to say we're going to move it by dx and by dy. And that's common in math and physics. That means a change in x and a change in y. So we could start off naively and just say canvas.move self.oval dx dy, and then I could say for spoke in self.spokes let's see, so it's an angle SX, an SY, and the ray. Canvas.move, ray, dx, dy. And that would move the wheel. So what we're going to do down here in draw scene, we're going to say root.after, and we're going to take 500 milliseconds, wheel 0.move, 20, 0. So that should move the wheel 20 pixels to the right is what we're hoping that does. So we draw our picture and our wheel moved, but it didn't roll. Maybe we'll do this and we'll just make move reinvoke itself, which is not ideal, but root.after 50, self.move, dx, dy. So now my wheel slides across but it's not rolling, and that's not very satisfactory. So now we have to make it rotate, and that's where this becomes much more complicated. So we're going to say angle. I don't need SX and SY because they're encapsulated inside the ray, so I'm going to get rid of that. So it's just the angle and the ray. Okay, so for angle, ray in self.spokes. Now first I need to get a delta angle, change in the angle. So that equals math.sqrt of dx squared plus dy squared. And if that doesn't look familiar to you, that gives me the distance that the wheel moved. And so if I know the circumference of the circle, which is equal to 2 times math.pi times self.radius, then I can say the angle equals circumference, dA over circumference times 360. So that gives me the angle in degrees that the wheel rolled. So I need to give this a different name since I already used angle. Ray angle, ray. Okay, let's do that. So now I'm going to say ray angle plus equals angle and let's see. So now the end of the ray is going to be at Rx, I called this Sx and Sy last time. Okay, well, I'm calling it Rx and Ry this time. Equals radius times math.cosine degrees to radians, ray angle plus was going to keep track of self dot. It's no longer x naught, it should be self dot x. Self dot x naught plus equals dx self dot y naught plus equals dy. Okay. So now I can say plus self dot x naught, and this should have been self dot radius, so I can get rid of that squiggly. Self dot radius sine degrees to radians dot y naught, and now I can say canvas dot chords self dot ray self dot x naught self dot y naught rx and ry, and that will set the coordinates of the ray, so that will move it. And now I need to say, okay, I need to change the contents of this. So this really needs to be for spoke in, and then ray angle ray equals spoke. And now I can set ray angle. So spoke sub 0 equals angle. So that updates the angle in each spoke. Now if I haven't done anything really wrong, undefined name ry, because I forgot to change that. There. Okay, that gets rid of that squiggle. This one's because the line is too long. Well, it's going to have to stay there for right now. Now, that should make the wheel roll. Let's see what happens. Nothing. Wheel object has no attribute ray. It's not self.ray, it's just ray. Okay. Doesn't look like it's rolling. So now we have to go back into the debugger. Okay. And we want to stop inside of move. Why has that got a squiggly? Too many blank lines. Huh. And why? Oh, that one has a squiggly because the line is too long. I shouldn't have changed anything because I'm debugging this. We'll get rid of the squiggly later. So we went to break on line 49. I meant to type that at the debugger, not in my code. Okay. Oh, okay, so we broke the debugger. My debugger is not as robust as the VS Code debugger is. So I end up having to restart it more frequently than the VS Code debugger has to be restarted. Okay, break 49. Okay. canvas.move self dot oval. So that made the wheel advance. Now we're hoping the spokes will advance and rotate. So if I ask about self, it just says that. It doesn't tell me the contents of self. Self.x0, self.y0, dx, dy. Okay. So the distance moved is dA, which should be 2 because I didn't move anything in y. Circumference is 314. Yeah. 2 pi r, yep. And so the angle is 2.29 degrees. Do I believe that? Actually, I don't. Circumference times 360. So what's dA over circumference? So I moved that much of a full turn, and so 360 times 0.006367 is the 2.29 degrees. Okay, I'll believe that. That's right. Okay. So if I print out the spoke, 0.0, that's the degrees, and then 2 represents the ray. So ray angle, okay, so ray angle is equal to 0. I'm going to increment it. Okay. Rx equals 101, because we're working on this ray right here. This is 0 degrees. So it's the x should move to the right almost 2 pixels, which is good. And the ry is 251, so it moves down almost 2 pixels too. Do I believe that? Yes, I do. Okay. So self.x0, self. I was supposed to rename those to x and y, not x0 and y0. So when I move that spoke, okay, that rotated and it moved, so it's now connected to the side of the circle. Okay, so the spoke, okay, so it updated that spoke. Ray angle 74. That's right, because we're going that way. Oh, went backwards. The first one went forward. Well, let's see. Yep, so the next ray moved backwards when it should have moved forward. So how do I know which way to rotate them? Why did that one work and this one didn't? move the right way. This is supposed to be ray angle. There's my problem. Because you'll notice they all have the same angle right now, which is not what I wanted. Okay, so let's try it again. Oh, look at that. Now, indeed, it looks like the wheel is rolling. It's a little jerky because I'm only doing it every 50 milliseconds. Let's drop that down to, if we cut it in half, it shouldn't be as jerky. Excuse me. Okay, that makes it a little smoother. And now the advantage of doing it this way is that I can have a second wheel still can't have wheels rotate to the left. I need to think about that. Think about which way the wheels should be moving. But now I can create another wheel. Wheel 1 equals wheel so 50 350 50 I'll give it 6 wheel 1.move and I think that wheel is going to spin the wrong way. Let's see what that does for us. Yeah, and so that wheel is spinning the wrong way, but it has 6 spokes at least, and we can see it's moving slower than this one. How do we figure out so what I really should do is instead of moving it in XY, I should have a rotation on it. And the rotation would dictate how far it moves. That's an interesting challenge. So for the moment, we'll just do this. Okay, so now we have an animation that looks physically correct. They're rolling the correct way, and we're pretty happy. Now, what I had hoped to do was to slant the line and show the wheel rolling down the line and going faster and faster as it rolled down the hill. But I had enough trouble getting to this point, and if you stuck with me this long, you're to be commended. So, what does that really show you? Hopefully it just gives you an idea of some of the fun you can have with graphics. And yeah, there are still things that I did wrong there. Like I say, if I tried to have both of those wheels moving positively, as we saw, then the bottom wheel is spinning the wrong way, and so there's still some work to be done on that. But you get the general idea, and you can see how you can do more and more complex animations. You've also seen how with a class you can associate data with behaviors. And we don't really do much with classes in this course, but this gives you a little bit of an idea of what can be done with them. And yeah, hopefully that's interesting to you. Thanks so much for watching.